Hello, this is Jeremy Comel and welcome to LipidMatch tutorial part 8. In this tutorial we'll be talking about imaging and direct infusion data and how to apply LipidMatch to analyze these types of data formats. So really they're very similar to data-dependent analysis. The conversion of the files into .ms2 format is exactly the same as in LipidMatch tutorial part 2. A difference, though, is how do you acquire a feature table? So if we look at some imaging data, and we select that data, we can average the mass to charge and intensity values across our entire imaging experiment. In this case, we're using a flow probe experiment on mouse brain. And now we can go to View, and this is for Excalibur for high-resolution data using a Q-Exactive. Spectrum list, and it will show us some of the top hits, and we can go to options, display options, and click, instead of top 20, we can click all peaks. And so this is the data we'll need for our feature table. So I'll press OK, and then export clipboard exact mass. Now I'm going to paste that into Excel. I'm going to remove any of these top parameters if they're not of interest to us. Remove any rows that are not of interest to us. So now we have a mass to charge column, an intensity column, and a relative intensity column. We need two more columns for LipidMatch. We need a row ID and we need a retention time. So for the row ID, let's create a new column. And I'm just going to number each feature from 1 to the last feature. So I'll go 1, 2, highlight both of these, click the bottom of the rectangle, the right bottom, and it will fill down. So now we have a row ID for each feature. In addition, we want a retention time, so I'm going to insert one after mass to charge, label it retention time. And so for the retention time, we look at our chromatographic run. And in this case, we have ran for 1 minute. Now, for that chromatographic run, then, we can put 0.5 or half of our chromatographic run and make sure that it fills 0.5 for each feature. And what we'll do is we'll tell LipidMatch to look in a retention time window of 1 or plus or minus 5 for each of these features. So it's going to look across the entire chromatographic run to look for MSMS scans. So this is just a way to trick LipidMatch, since LipidMatch is built for chromatographic data. So we can save this file. Look, we did it in negative mode, so we're going to save it. Go to our desktop. Imaging data, and so our inputs, and we'll save this with a name that should end in negative. So I'll just say DD, or it's a feature table, so you don't even need DD, brain negative.csv. And so we're going to do the same thing for our positive mode data. In this case, let's just run negative mode data for brevity. So I'm going to close this. Now I want to note here that in this file, we have scans across time, and what I did for an imaging file is every so often you can take a data-dependent scan in your method file, and you want to either set the dynamic exclusion, for example, if you're using an Orbitrap, to the full time in which you're going to run the acquisition. And that way, as you take data-dependent scans, it will never select the same precursor ion for fragmentation, and you'll end up getting all the possible precursor ions through that retention time, the highest abundant ones, fragmentation for those. Then, of course, you can convert this to a .ms2 file as described in tutorial 2. Now we'll run LipidMatch. Let's look at our LipidMatch input. So we have a negative, and let's remove the positive, then .ms2 file. And so this is all we need for negative analysis. We have a feature table and a data-dependent file. Let's run LipidMatch. Control A, click Run. We're not going to download the newest version of R. And now we'll go to our imaging data, LipidMatch input, press OK. And then for the libraries, again, we're going to just use the libraries that come with LipidMatch. And then we can select for the retention time window, again, so we had a 1 minute run, and we put our retention time as 0.5 minutes for every single feature. So if I put a window of 1, that's going to be plus or minus 0.5. So you're going to get 0 to 1 minute. It's going to look for scans. So you want it to look the entire scan. So 1 minute, so you just put whatever the runtime was for your imaging or direct infusion experiment. Then all these other parameters should be very similar to if you were to do an LCMS experiment. So you could look at tutorial number 3 for more in-depth explanation of these parameters. Default. Again, our feature, we had our row ID in 1, mass of charge in 2, retention time in 3, and our data started in row 2. And then the number of scans required for identification, especially if you're using only that dynamic exclusion method for your entire run, you're only going to get 1 scan for each precursor, so you definitely want to use just 1 scan. Click Run, and it will generate an output folder. Let's look at some example outputs. Again, if you wanted to look at your feature table like we generated before, we can see that we have our ID, our retention time, mass to charge. A little different file format from our example data, but same idea. And now you can get your IDs. In this case, we have 3 identifications for that run, their intensities, their class. And so that's useful information to us. We can look at our positive IDs too. If you look at the only IDs, it won't give you a feature table. It will just give you which identifications you may have gotten. And so that summarizes LipidMatch tutorial part 8. Thank you.